Now, other than this, there are also two more types of variants, or I would say just one more type of variant, where we allow the transaction to upgrade and downgrade. Now, what that means is upgrading means converting an S lock into an X lock. S stands for shared lock and X stands for exclusive lock. So this is the point where initially, when the transaction simply needs to read the data item, the transaction will only obtain a shared lock. But when the transaction wants to write that data item, then it will change its shared lock to an X lock. Now, what is the benefit of that? The benefit of that is as long as the transaction holds a shared lock, another transaction can also obtain a shared lock on that data item and doesn't have to wait. But if the transaction from the beginning itself obtains an exclusive lock, then another transaction cannot obtain even a shared lock on that data item till the lock is released. And that's why we allow upgrading. Upgrading can be done only in the growing phase of the two-phase locking protocol. The next phase which can be allowed is known as a downgrading phase, where once the transaction has finished writing that data item, the transaction can release the exclusive lock and change it to a shared lock. So it still holds a lock, but it has not, released it. It has not unlocked, but it just changed the lock from exclusive to shared. So this is known as downgrading, and this can be done only in the shrinking phase of the two-phase locking protocol. So that's how you can have all types of variants to two-phase locking protocol to make it stricter, to make it more reliable. Now, the next protocol that we are going to see is known as a timestamp-based protocol. So as the name suggests, in this, each transaction Ti is given a timestamp. And so the timestamp is denoted by TS in bracket Ti. So that's called a timestamp. So if you have a transaction Ti, and suppose Ti is arriving first, and then there's a transaction Tj, and it arrived second, then the timestamp of Ti will be less than the timestamp of Tj, because Ti came first. So you can just assign a timestamp based on the system clock. You can note down at what time each transaction came, and you can give that time and date to the transaction if you wish. Or you can put a counter variable that counts the number of transactions coming. So if this is my 10th number transaction, then this transaction would be given a timestamp of 10, and Tj would be given timestamp of 11 if it comes after. So there are several ways of assigning timestamps. We're not going to discuss more about how to give timestamps, but we are going to discuss more about how the protocol itself is implemented once timestamps are assigned. The only thing you need to remember is that the timestamp of a transaction that arrived early would be less than the timestamp of a transaction that arrived late. Now, what happens to data items? Only transactions are not given timestamps. Even data items are given timestamps. So consider there's a data item Q. Then this data item is given two timestamps. The first timestamp is a W timestamp, which denotes the largest timestamp of any transaction that executed a write Q operation successfully. So largest timestamp, that means if this data item Q was written by, say, 5 transactions and their timestamps were 1, 2, 3, 4, 5, then the data item Q's W timestamp will be 5 because that's the largest timestamp of any transaction that wrote this data item Q. Of course, afterwards, if another data item comes, another transaction comes like with a timestamp 6, then the W timestamp will become 6. And other than that, we have the R timestamp. So R timestamp denotes the read timestamp, which is the largest timestamp of any transaction that executed a read queue successfully. So if there are 5 transactions reading this data item queue, then the R timestamp will be equal to the timestamp of the transaction having the largest timestamp. So if 5 transactions are there and they have timestamps 1, 2, 3, 4, 5, and all of them are reading data item queue, then data item queue will in the end get the timestamp 5, the read timestamp 5. So that's how we assign timestamps to transactions and data items. Now let's see how to apply the protocol. So now we're going to look at 2 scenarios. The first scenario is where a transaction is trying to read a data item, which is Q in this case. And we're going to see the second scenario. In the second scenario, a transaction is going to try to write the data item. So first scenario is about reading, second is about writing. So in this case, assume that there is a transaction Ti that is trying to read the data item Q. Now, and when can we allow Ti, or when can the system allow Ti to read the data item Q, and when can it not allow this Ti to read the data item Q? Let us see. So if the timestamp of Ti is less than the write timestamp of Q, then Ti needs to read the value of Q that was already overwritten. Hence, the read operation is rejected and Ti is rolled back. The reason for this is some other transaction has already overwritten the value of Q, and you don't want that value to be read by Ti. So if the timestamp of Ti is less than the write timestamp of Q, then Ti is not allowed to read Q and it is rolled back. And I've already explained what rollback is. Rollback is when you take the transaction right to the beginning and start again. Now, what other thing can happen? So the second thing is if the timestamp of Ti is greater than or equal to the write timestamp of Q, then in that case, the read operation is executed. And the R timestamp, the read timestamp, is then set to the maximum of R timestamp and TS of Ti. So let me explain that a little bit if you didn't get it. So the first case we saw was where the timestamp of Ti was less than the W timestamp of Q, in which case we are not allowing Ti to read the transaction, to read the data item at all. But if the timestamp of Ti is either greater than or equal to the write timestamp of Q, then in this case, we perform the read operation. But after doing that, we also need to update the read timestamp of Q. To do that, we check, suppose the read timestamp of Q is right now 10, and my transaction, which is Ti, is having a timestamp of 5, then we are not going to update the timestamp at all because it is less than 5 is less than 10. But if the timestamp of the data item, the read timestamp, R timestamp, is 10 and the transaction Ti is having a timestamp of 11, then we will update the R timestamp and make it 11. So this is the first scenario that I told you about, where we are considering a transaction that is trying to read the data item Q. The second scenario is where the transaction Ti is trying to write the data item Q. So in this case, if timestamp of Ti is less than the R timestamp of Q, then the value of Q that Ti is producing was needed previously, and the system assumed that that value would never be produced, and hence the system rejects the write operation and rolls Ti back. So to perform write operation, we need to check the read timestamp. So just don't get confused with that. To perform a read operation, we checked the W timestamp. To perform a write operation, we are checking the R timestamp. Now, if timestamp of Ti is less than R of Q, then we are simply going to reject the write request and roll back TI. Next case is if the timestamp of TI is less than write timestamp of Q. In this case, TI is trying to write an obsolete value of Q because there's already some bigger transaction which came after TI that has already updated the value of Q. So there's no point in making TI overwrite the recent value of Q. And hence, once again, the system rejects the write operation of TI and rolls TI back. What other case can be there? The third case is the otherwise case, which is when the first case is not true and the second is not true. So this is the otherwise case. Otherwise case would be where TI is having a timestamp greater than the read timestamp of Q, greater than or equal to, and also greater than or equal to the write timestamp of Q. If both are satisfied, then the system executes the write operation and it will set the write timestamp of Q to the timestamp of TI. So that is how a timestamp based protocol works. And if you find it a little bit difficult at first, I just ask you or request you to just go through it once again, and I'm sure you'll get it. So that's it for this video, and I'll see you in the next one. Thank you for watching.